What's up, YouTube? In today's video I'm going to show you how to solve the 2x4x4. So let's go ahead and mix this up. Alright, that's looking pretty good here. I'll separate these and now we can shape shift it. Alright, so that's looking like a pretty good scramble. Now on the side here I have my little cheat sheet. I wrote this. Here are the 2x3x3 algorithms. I will be referring to this, and 4x4 algorithms, which I will be referring to this. So the first thing you want to do is solve it as a 2x2, solving the corners. So say we'll start with yellow. Now I see here's a yellow and red. Now we'll look for another yellow and red corner. We have it right here. So we want this to be, it's where it belongs, just needs to be oriented correctly. Like so. Okay, now we need these two. This one does not go here, it needs to be blue. There we go. Now it's correct. Now we need the last corner in here. Okay, so now we have the first layer of a 2x2. So then we flip it upside down and get the second layer. Oh, whoops. Okay, now you can see we solved the 2x2, only focusing on these corners. Now the second step is to return it back to its original form. So what we want to do is, like we have this here, that is going to go up here. So we also want to make another one on the opposite side, like this, so that we could just lay it flat. I'll show you what I mean. We have this, and on the opposite side we have this bar here. So we could just match those up, like so. So when we spin this, it goes back to how it should be. Alright, now we want to do the same thing here. We have two here, so we want two here. What we can do is rotate this. Now that matched up, and we can, let's see, we could take this whole corner, bring it up to the top. Okay, and then put it right here. And now we can rotate this so it's lined up there. The algorithm that I used to switch these two, I call it the corner dropping algorithm, which it is 2R, U, 2R, U prime, 2R, and it switches this here with this. And you could either do your 2R like this if you want to switch this whole chunk, or this is your 2R if you just want to switch the corner. Now if we come across a situation like this, where we have, say, two pieces that still need to be flipped in order to restore the original shape, we could do one of two things. We can either use the Red Bull algorithm, which flips two pieces right here. In order to do that, we would need the pieces to be together. So we can bring this back here and then spin it up. Now that algorithm would flip these two. So if we come across this where the two edges that need to be flipped are right next to each other, we can do the 4x4 parity algorithm that flips them. It is the Red Bull algorithm, and it looks like this. I'm using, when I say R, it's like a little r, and then B is going to be this, and F is going to be this. So it's 2R, 2B, 2U, L, 2U, R prime, 2U, R, 2U, 2F, R, 2F, L prime, and let's just finish it off, 2B, 2R. You could see that restored the shape. Now, if we come across a situation that happens a lot on a 5x5, I don't really consider it parity, but I'll show you what it looks like on a 4x4. So this one is where this piece and this piece switch, and white is pointing to the sides. So we could either do the Red Bull algorithm like this, which would flip them, or we can do this algorithm, which is used on a 5x5 to switch these two. So say you have this case here where there are two that are flipped, and you can, if you want, put them next to each other to do the Red Bull algorithm, or if you prefer to do the 5x5 edge pairing algorithm, you can just put them opposite each other, like so. And you want to hold them on the right side, just like this. And you want to perform the algorithm as follows. It is L prime, 2U, L prime, 2U, 2F, L prime, 2F, R, 2U, R prime, 2U, 2L, and that puts it back in its shape. Okay, now we want to match up both the centerpieces. So we're good there. And now we want to hold the cube like this. Alright, now what we're going to do is solve all of our edges just like we do on a 4x4. But this time we're kind of limited with how we can move it since it is a cuboid. So I'm going to look for any two pieces that are the same. Okay, right here is a white and green, and right here is a white and green. Now you need them to be able to twist and match up. So I'm going to take this and spin it over here. Now it's down here. Now we can match these up, and we can bring it up to the top, replace it with something and bring it down. So this is already matched. Right here, this is unmatched, but if we just bring that up, it'll knock that down. So what we could do is take this out of the way. Now bring the completed edge up, put this in its place, bring it down, and just restore it. Okay, so look for another two that are the same. Right here, here's a blue and yellow. Here's a blue and yellow. So that's not going to work. What we could do is that. Now we can match them up like so, and bring it up to the top, and we'll replace it with this. So let's get that out of the way. Bring this up, replace it, bring it down, and restore it. Now we have this here and this. So now it's over here. And we'll replace it with this. So we have this one and this one here. Okay, now let's get this out of the way. Bring this up. Put this in its place. Okay. And there you have all the edges complete. If you come across the situation where after pairing all of the edges together, you have 2 left, you can see everything else is solved. Now in this case, you can't just put them opposite each other and rotate it because there is nothing on the top or bottom to replace it with. So what we will have to do is put them on the same layer opposite each other, and I'm going to use both the Red Bull algorithm for the 4x4 and a algorithm for 5x5 edge pairing that does this. So first, I know that I want this one to be stationary, so I can use the 5x5 algorithm that switches these two once I have the blue and yellow right here. And the blue and yellow is right here. So we know we could use the Red Bull algorithm to switch these two so that we have this over here. So let's do that. Let's do the Red Bull algorithm. It is 2R, 2B, 2U, L, 2U, R prime, 2U, R, 2U, 2F, R, 2F, L prime, 2B, 2R. And that successfully flipped these two and switched them. So now you can see the blue and yellow is in line to go right here, and the green and white can go right there. So now we will use the 5x5 algorithm, and this looks like this. It is L prime, 2U, L prime, 2U, 2F, L prime, 2F, R, 2U, R prime, 2U, 2L. Now these two are matched up, and these two are matched up. Now we just have to flip these back, and it will restore the shape. So we will use the Red Bull algorithm. It is 2R, 2B, 2U, L, 2U, R prime, 2U, R, 2U, 2F, R, 2F, L prime, 2B, and 2R. Now you can see these are back where they belong and they're matched up. So are these. We have it back to the cuboid shape. Now let's solve it as a cuboid. Now when you get to this point, this is basically a mixed up 2x3x3. Okay, so picture this piece here as the middle, this as an edge, this one as a corner. So you can see it has 2 layers, and then right here are the 3, right there are 3. So just as we would here, we would make a cross. So let's go ahead and do that. So with this, I'll make a white cross. Now the next step is to put your corners in. So with a cuboid, if red is facing down, then you want to put the corner that belongs in here over where it needs to go. So you can see the red is going to face down, green is going to be right here, so these will match up, and yellow is going to be right here, so these will match up. We're going to hold it to the front right, and we're going to do the corner dropping algorithm. So this is 2R, U, 2R, U prime, 2R. And you can see it went right here. Now we do the same thing, we find another red corner right here, and this is red, green, and white. So it's actually over where it needs to go, the red, green, and white, and these are opposite, almost like an X. White, white, green, green. We're going to hold it in the front right and do the corner dropping algorithm, which drops the corner. So it's 2R, U, 2R, U prime, 2R. You can see it went down there. Now here's another red corner. We have red, white, and blue. So red, white, blue needs to go right here. So we'll put it over where it needs to go. And again, you can see the little X here. And do corner dropping algorithm, it's 2R, U, 2R, U prime, 2R. And it goes in place there. Now the last corner is right here. It's the red, blue, and yellow. So we have red, blue, yellow. It's over where it needs to go. So 2R, U, 2R, U prime, 2R. Now we solve the first layer. So we will do the same thing on here. White is facing down. Now here's a white corner. We have white, red, and green. So white, red, green needs to go right here. Again, you can see the little X here. White's going to go right here. So we go 2R, U, 2R, U prime, 2R, and it's in place correctly. Now here's another one. It's the red, white, and blue. We will put this over where it needs to go. Red, white, and blue, so it needs to go over this spot right here. And then we're just going to drop the corner. So it's 2R, U, 2R, U prime, 2R. Now we have two left. We'll pick either one, say this one. Green, orange, and white. So green, orange, white needs to go right here. So we put it over where it needs to go and drop the corner. It's 2R, U, 2R, U prime, 2R. And the last one is blue, orange, and white. So blue, orange, white needs to go right here. Put it over where it needs to go. 2R, U, 2R, U prime, 2R. Now we solved that first layer. So for the second layer, what we want to do is find any two pieces that are the same color, such as these two. And it doesn't have to be three like that, it could be like this. So you want to find any two that are matching and put it on your left face. And you want to do the corner permutation. So this switches the corners around. In this case, it will switch these two. This is basically a T-perm for cuboids. First you do your corner dropping algorithm, which is 2R, U, 2R, U prime, 2R, and then you want to go U prime, D, and now you do 2R, U prime, 2R, U, 2R, and that permuted the corners. So we will do that here. Here we have two of the same, so we're going to put this on our left face. 2R, U, 2R, U prime, 2R, U prime, D, 2R, U prime, 2R, U, 2R. Now, these are all permuted, so we will just match them up to where they need to go, and now we only have to permute the edges. So permuting the edges here, we have an adjacent swap. So this one is 2R, U, 2R, U, 2R, 2U, 2R, 2U, and then the corner dropping algorithm. It's 2R, U, 2R, U prime, 2R. and solved. So right here, first thing we can do, I see blue is back here, so we could switch this one and this one. This is an edge swap. So the edge permutation for opposites looks like this. It's 2R, 2U, 2R, 2U, 2R, 2U. So it's a pretty easy one to memorize. Now we can do the same thing. We can swap this orange back here, so this green will come here. It's 2R, 2U, 2R, 2U, 2R, 2U. And we have one more left. This right here is the adjacent edge permutation. So it's 2R, U, 2R, U, 2R, 2U, 2R, 2U, and the corner dropping algorithm is 2RU, 2RU prime, 2R. And we completed it. One more thing I want to go over. If you're solving for this first layer right here, and you see this corner isn't in correctly, and this one is also not in correctly, you don't have any reds up here to drop down, but what you can do is take one out. Because remember, the corner dropping algorithm not only drops this one, but it brings this one up in its place. So let's take this one out. 2RU, 2RU prime, 2R. Now you can see that corner went up here. Now we can put it over where it needs to go, and this one will take this out. So it's 2RU, 2RU prime, 2R. Now that's in where it needs to go, and this one will go back here, over where it needs to go. 2RU, 2RU prime, 2R. Now that's solved. So I'll just finish this up real quick. It's like a J perm. Okay, now we have these three. So there we go. Alright, thanks for watching, and I'll see you in my next video.